Hi, this is the last lecture on SQL. Okay, so the last topic we'll talk about is views. So in some cases, it's not desirable for all the users to see the entire logic. There could be some information that, you don't want everyone knowing, such as your salary, right? So in SQL, you can limit what people can see by not putting that attribute in the select statement. So we have select ID, name, department, which are not necessarily, sensitive, right? And then you don't see the salary here from instructor. So by doing this, you're able to hide the salary information. So a view provides these kind of mechanism. It's to hide certain data from certain other users from viewing. Okay, so it's like a virtual view. So you can create view. So this is a syntax. Create view, and then this B is, that will be the name of the view, as, and then this, you'll have your SQL query. Okay, so here we have a view called faculty, okay, and we are outputting the ID, name, and department, and it doesn't have the information about the faculty or the instructor's salary. Here I have another view, so we have select, name, from, and so faculty, as you can see here, is used just like any other relation, such as instructor, but we are actually calling this particular relation where department name is equal to biology. You can also create a view of department salary totals. Okay, so we have create view. The name of the view is called department total salary. And you can also indicate the names of attributes. And here we're going to call them department name, comma, total salary. Okay, and you have as, and this is the actual relation. So select department name. Okay, it's still called department name, comma, sum of salary, and this got a new name called total underscore salary. Okay, from instructor, we're going to group by department name. Okay, just to review, whenever you're using any kind of aggregate function, you can only output that. The only thing else that you can output is if you group by something, that's another thing you can output. If you have something else here, then that will give you an error. Okay, here we have another view called physics underscore fall underscore 27. And then we have that as we're joining course and sections. And this is going to be a Cartesian product. Okay, where the course ID from these two tables are the same. And we want the department name to be physics, semesters fall, and year is 2017. And we're outputting the course ID, section ID, building, and room number. Here we have another view called physics underscore fall underscore 2017 underscore Watson. Here we are calling the view that we just defined called physics fall 2017. So that's in the from clause, okay, where building is in Watson. So this is returning all the courses that are offered, physics courses that are offered in fall of 2017, and the building should be in Watson. Okay, so this is a view that we defined, and we are able to use another view, which we had defined earlier, physics fall of 2017, this one. So if we hadn't defined this, then we would have to put this whole thing in here, which would look something like this, right? So as you can see, it's very busy, it's very long, there's a lot going on, and you cannot really tell immediately what it is. So I think it's really useful if you have a complex query, really long, just by dividing it up. So here I can tell that this is returning all the courses, physics courses in fall of 2017, and this is in fall of 2017, but in Watson building. Okay, so if you have a long complex query, make sure you use views. So our last set of exercises we have here, it's going to be on the same thing, sailors, boats, and reserves. Okay, number 12, find the names of sailors who have reserved every boat reserved by those with a lower rating. Okay, so the keyword here, I hope you noticed that it's going to be every or all. Okay, so we'll take about 5 minutes. Okay, so once you're done, go ahead and click play. Okay, so it's going to be a combination of not exist, subquery, except another subquery. Okay, so whatever that appears before every and after every, right? So we are looking at reserved every boat. Okay, so that boat should go here. Okay, and then those with the lower rating will go here. Okay, so select the names of sailors. So we're going to call it S1. So S1.S name of the sailor from S. And then we have where not exists. So again, not exists will return true if whatever following it is empty, right? So whatever boat IDs were returned here, and then we're subtracting the ones that were returned from the second set of subquery, we want that to be empty. Okay, so let's take a look at the first subquery. So just look at it and see, just in plain English, what this is returning. What is this? This 3 lines of code is returning. Okay, so it's looking at rating, right? So we want to return the ones where okay, so the first one is going to be returning a bunch of boat IDs. So is the second one. So they're both going to be boat IDs. We have boat, reserves, and another sailor. Okay, and then here the another sailor's rating is less than the sailor that we're looking for. Okay, so that's S2 are those with the lower rating. Okay, and then we have S2 SID is equal to, so their SID is equal, it's in the reservation. So basically the first set of subquery will return all the boat IDs reserved by sailors with a lower rating than S1's rating. Okay, so what about the second one? Okay, so here it's going to be a bunch of boat IDs and then we have reservation. Okay, so R2 that boat ID, so it's the same boat IDs from the reservation. Okay, and then the SIDs are the same. So these are going to be all the boats reserved by S1, right? All the boats reserved by S1. Okay, so these are going to be all the boats reserved by sailors with a lower rating than S1. These are all the boats reserved by S2 and this is S1. So this will return the names of sailors who reserved every boat whose rating is lower than S1, who we're looking for. Okay, numbers 13 and 14. For each rating, find the average age of sailors at that level of rating. So whenever you see, for each something, we know that we're going to be grouping by something, right? Okay, and number 14, for each boat, which was reserved by at least 5 distinct sailors, find the boat ID and the average age of sailors who reserved it. Okay, so once you're done, click play. Okay, so for each rating, so we're going to be grouping by rating. We want to find the average age. So it's an aggregate function age, and in parentheses we'll have age. Okay, and that can be found in S table, so we're going to be calling S. Select rating, comma, average age from this table. Okay, group by rating. So we are outputting the average age for each rating. Okay, 14, for each boat which was reserved by at least 5 distinct sailors, we want the ID of the boat and the average age of those who reserved it. So we want the boat ID and the average age. Okay, it's going to be from all 3 tables, B, R, and S. So when you join these 3 tables, these are Cartesian product, so we have to specify which attributes we want them to be equal to each other. So we have S, the SID, that's the sailor's ID. We want that to equal to the SID from reserves. And then BID from boat should equal to the boat ID from reserves. So we have that condition right here. And then it said for each boat, right? So we know that we're going to be grouping by boat, which is boat ID. Okay, so group by boat ID, and then we have this condition where the reservation should be at least 5 different sailors. So we're counting different instances, so that's going to be count. In parentheses, we have distinct r.sailor ID. If you don't have distinct, it's going to count the same sailor more than once, which wouldn't be accurate, right? So make sure you have the distinct here. Yeah, the last two can be a little bit tricky. They sound very similar, but they're not. So let's just read over. The first portion is the same. It's for each boat, which was reserved by at least 5 sailors with age greater than or equal to 40. So that's the same part. Okay, 15 is asking for find the boat ID and the average age of such sailors. So meaning these sailors, this should meet the age criteria. So we want the average age of sailors who meet this age criteria, which they should be greater than or equal to 40. Okay, and then 16, it's similar, but then it's finding the boat ID and the average of the age of sailors, all sailors, it doesn't matter what age they are, who have reserved such boats. Okay, so that's the difference here. Okay, let's go over number 15. So we are looking for the average age. So for each boat, so that means we're going to be grouping by boat ID. So we're going to do select boat ID, comma, average age. It's going to be from all 3 tables. And again, we're doing the same thing. So SIDs from S and R are the same. And then the boat ID from B and R are the same. Okay, where sailor's age is greater than or equal to 40. Okay, and we have these 2 conditions grouped by boat ID. Okay, and then the distinct SIDs are going to be greater than 40. Okay, so here we are taking the average age of such sailors. Okay, 16 is a little bit more complex because it doesn't matter if the sailor's age is 40 or less than 40. As long as they have reserved such boats, we want to count their age towards average. Okay, so we have select B1.BID. Okay, and then because we're grouping by BID, and then average age of the sailor S. Okay, and here we have RS. Okay, and then we have another one. This is a subquery in the from clause. Okay, so what does this subquery return? So select boat ID from B, comma, reservation R2, and then another sailor S2. Okay, here we are setting those boat IDs and SIDs to equal to each other, and then this is going to be the age of the sailor grouped by boat ID. So this is returning all the boats that at least 5 sailors of this age have reserved. Okay, so that whatever was returned there, those boat IDs were returned. Okay, so that along with the R and S. Okay, so the sailor out here, this S alone, it doesn't really matter what their age is, so that has nothing to do with it. Okay, that's not part of the calculation when we do the average age. Okay, where the boat IDs and the SIDs are equal to each other, and we are grouping by boat ID. So here, when you're computing the average age, the sailor's age didn't matter. This one, it does. Okay, so we're kind of separating out this criteria.